Hello guys, uh, today we are solve exercise 1.2 question number 3, 4, 5, 6 and 7. Okay, let's see what question number 3 is saying here. So here question number 3 is saying find the LCM and HCF of the following pairs of the following it's not pairs of the following integers by applying the prime factorization method. Guys, we know that how to find LCM and HCF by applying prime factorization method. Because in previous question we have already discussed about both method. First one is prime factorization, how to find HCF by prime factorization method and how to find HCF by division method. And we know that how to find LCM also. So let's see here three numbers is given. And first question is 12, 15 and 21. Second question is also given here, which is 17, 23 and 29 also. Now come to the question number third. Question number third is given here 8, 9 and 25. So now I'm going to solve question number first. So question number first is saying find the LCM and HCF by applying prime factorization method. First up at all, I'm trying to find LCM of these three numbers. First one is 12, 15 and 21. So you can see 21 and 15 is not divisible by 2, but 12 is divisible by 2. So I go with 2. Here I get 6, 15 and 21. 6 is also divisible by 2. Again I go with 2. You get here 3, 15 and 21. Now you can see three numbers which is remaining here. All is divisible by 3. So 3 ones are 3, 3 5s are 15 and 3 sevens are 21. 5 is divisible by 5 and 7 is also divisible by 7. So I go with 7 here. Now LCM of 12, 15 and 21 is equal to, what is the prime factor of this number? So it is 2 into 2 into 3 into 5 into 7. So 2 2s are 4, 4 3 is 12, 12 plus 5 is 60 and 60 plus 60 into 7 is 420. Now same way I am doing prime factor of these numbers and find to HCF of the numbers. So first of it all, first number I am taking, which is 12. So when we are doing 12 prime factorization of 12, so I will go with 2, I will get here 6. Again I go with 2, I will get here 3. Again I go with a 3, will get here 1. Again I am going to do next number, prime factorization of the next number, which is 15. So I will go with 3, will get here 5, and go with 5, will get here 1. So next number, which is 21, I will go with 21. So 21 is divisible by 3, will get here 7, and 7 is divisible by 7, will get here 1. So HCF of these two numbers. First of all, we have to see here 12, prime factorization of 12 is 2 into 3, and prime factorization of 15 is 3 into 5. And also prime factorization of 21 is 2 into 7. Sorry, 3 into 7. So you can see what is the highest common in these three numbers. You can see here is also 3, here is also 3, and here is also 3. So in three numbers, which is 12, 15, and 21, highest common is a 3. So I can write here HCF of 12, 15, and 21 is equal to 3. So we have to find the LCM. LCM is a 420 and HCF is a 3 here. This is the answer of question number first. Now comes to the question number second. So you can see in the question number second. So in question number second is given three numbers, which is 17, 23, and 29. When we are finding LCM of these three digits, it's 17, 23, and 29. No one number is divisible by another numbers. These numbers are divisible by itself. 17 is divisible by itself. 23 is also divisible by itself. And 29 is also divisible by itself. So LCM of these three numbers is equal to 17 into 23 into 29. Let's multiply it. So 23 into 29, 9 3s are 27, carry forward 2, 9 2s are 18, 18 plus 6, 18 plus 6 will be 24, 24 plus 2 will be 26, carry forward 2, and 2 2s are 4 plus 2 will be 6. So 667 multiplied with 70. 7 sevens are 49, carry forward 4, 7 6 are 42, 42 plus 6 will be 46, carry forward 4, 7 6 are 42, 42 plus 4 will be 46 here. Now 1 into 7 will be 7, 1 into 6 will be 6, here is also 6. Now sum, this is 9, and 7 plus 6 will be 13, carry forward 1, 6 plus 6 will be 12, 12 plus 1 will be 13, carry forward 1, and 6 plus 4 will be 10, 10 plus 1 will be 11. So you can see LCM of this number is 11,339. Now I'm going to find the HCF. In that situation, here is nothing is common. Because when we are finding prime factorization of 17, so you will get here 17 only. In that situation, if you are going to find the prime factorization of 23, so you will get 23. When we are doing 29, so you can get 29. So here is nothing is common in that situation. So what is the HCF of these numbers in that situation? In that situation, you can see all numbers are divisible by these three numbers is divisible by 1. So I can say that HCF of these three numbers, HCF of 17, 23, and 29 is equal to 1. This is the HCF, and here 11,339 is the LCM. Okay. Now comes to the next question of question number 3. So third one is here. So third question is 8, 9, and 25. We have to find the LCM of this number and also the HCF by prime factorization. When we are doing prime factorization of three numbers, you can see 25 is not divisible by 2, 9 is also not divisible by 2, but 8 is divisible by 2. So I go with a 2, so I get here 4, 9, 25. 4 is also divisible by 2, and 2 is also divisible by 2. And 9 is divisible by 3, so I go with a 3, I will get here 1, 3, 25. Again you can see 3 is here, so this 3 is divisible by 3, here is a 25, and 25 is divisible by 5, so I can write here, I will go with a 5, so we'll get here 1, 1, and 5 here. Again I go with a 5, I will get 1, 1, 1. So what is the LCM of these three numbers? So LCM of 8, 9 and 25 is equal to, it's 2 into 2 into 2 into 3 into 3 into 5 into 5. When we are multiplying, 2 into 2 will be 4, 4 into 2 will be 8, 8 into 3 will be 24, and 3 into 5 will be 15 into 5. So 15 for 5 is 75. So 24 into 75, we will do multiplication. 24 into 75. So 4 5s are 20, carry forward 2. 5 2s are 10, and 7 4s are 28. 28 plus 10 will be 20. 8 plus 10 will be 38. 38 plus 2 will be 40. Carry forward 4. 7 2s are 14. 14 plus 4 will be 18. So LCM of these two numbers is 1800. Okay. Now again we find the HCF by the prime factorization. Okay. So what should do? We should find prime factorization of three numbers. So prime factorization of 8 will be 4, 2 and 1. Again prime factorization of 9, when we are solving we will get here 3 and 3. And 25 we will get here 5, 5. In a prime factorization you can see nothing is common in three numbers. So what we have to do? We have to do which thing we do in a previous question. One is common in that number because every number is divisible by 1. So HCF of 8, 9 and 25 is equal to 1 here. Okay. Now come to the next question. Next question is 4 number questions we have to solve now. Now question number 3 exercise 1.2 is completed. Okay. Let's see question number 4. So question number 4 here, given that HCF 306 and 657 is equal to 9. And question is saying find the LCM. Find the LCM. One thing we know that, a formula we know that, which is HCF into LCM is equal to first number into second number. So here question is saying find the LCM. So what we have to do? Here HCF in a multiplication, when I transfer this HCF from left hand side to the right hand side, its sign will change. Okay. So here it will be first number into second number. Here HCF in a division multiplication, it's come in a division. So I can write here HCF. Okay. So what is the LCM? I don't know. We have to find the LCM. But we know that first number is a 306. So I can write here 306. Into second number, we know that which is 657. So I can write here 657. Upon HCF is also given, which is 9. So I can write here 9. Now we have to calculate it. So 306 is multiplied by 9. Okay. So when we are cut with 3, we will get here 102. Now it's also divisible by 2, 3. So I will get here 3 3 is 9 and 3 4 is 12. So LCM is equal to 34 into 657. So when we are finding LCM of these two numbers, we have to multiply in these two numbers. So multiplied of these two numbers, let's see what is the multiplication of these two numbers. So 7 4 is a 28, carry forward 2. 4 5 is a 20 plus 2 will be 22, carry forward 2. 6 4 is 24, 24 plus 2 will be 26. 3 7 is a 21, carry forward 2. 3 5 is the 15, 15 plus 2 will be 17, carry forward 1. and 3 6 is 18 plus 1 will be 19. Now here sum is 8, 3, 13, carry forward 1, 9 plus 2 will be 11, 11 plus 1 will 12, carry forward 1, and 1 plus 1 will be 2. So now LCM is 22,338. So this is our answer. So guys, are you getting how to do if HCF of any number is given and saying find the LCM of these numbers and two numbers is also given, then we have to do this type of things. Okay. Now come to the next question. Next question is question number 5th here. So come to the question number 5. What question number 5 is saying? Let's see. Question number 5 is saying check whether 6 to the power n can end with the digit 0 for any natural number. N. So here we have to take if any natural number is the power of a 6, we will get the digit is a 0, which end with 0. Okay, it means which unit place have 0. Let's see if one thing notice here, if the number 6 to the power n ends with the digit 0, then it should be divisible by 5, because we know that the divisibility rule of 5. What is the divisibility rule of 5? We know that number with a unit place is a 0 or a 5 is divisible by 5. But you can see when we are doing prime factorization, of 6 to the power 1, we will get here 2 into 3 to the power 1, sorry, n. So you can see here in a prime, when we are doing prime factorization, we will not here get 5. So I can see that 6 to the power n is not divisible by 5. So no any chances which digit we find on unit place is a 0 there. So hence it's clear. Hence it's clear that for any natural number n 6 to the power n is not divisible by 5. Okay, so thus it proves that thus it proves that 6 to the power n can't end with the digit 0 for any natural number n. This is the answer of question number 6. Now comes to the question number, sorry, is this is a question number 5. Now come to the question number 6. So our next question is question number 6. Let's see. So question number 6 is saying here, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. So first of all, we have to know that what is the composite number. So guys, by definition of the composite number, we know if a number is a composite, then it means it has factor other than 1 and itself. Therefore, the given expression, so first of all, I am dealing with first expression. So first expression is that which is 7 into 11 into 13 plus 13. Okay, this is the expression. So you can see here I am taking if 13 is a common, so here is a 77 plus 1, which is a 78. So 78 into 13 here. Okay. So when we are doing prime factorization of 78, what we have to get here? So we'll get here 3 into 2 into 13, and here 13 is already given, which is 13. Let's see what is the prime factorization of 78. I'm right or wrong. When I go with a 2, we'll get here 3. Sorry, it's 3. Yes, right. It's a 3. Here is a 9. Now 39 is divisible by 3. We'll get here 1 and 3, and 13 is divisible by 2. So prime factorization of 78, we can write 3 into 2 into 13, and 13 is already given. So you can see, according to the definition is saying that mm, definition is saying that it means that it has factor other than 1 and itself. So here also factor other than 1 and itself. You can see here is factor is 3 to 13 also. So we can say that this expression is composite number. Okay. So I can say that hence 7 into 11 into 13 plus 13 is a composite number. Now comes to the next expression. In that question, given a next expression also. So here the next expression is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 here. So when we are multiplying, what we will get here, let's see. In that both number 5 is a common. When I am taking 5 is a common. So here is a 7 into 6 into 5 into 3 into 2 into 1 and plus 1 here. Okay. So when we are multiplying 7 into 6, it's a 42. When we are multiplying this number, we will get here 42. Here we will multiplying with a 5 into 3, we will get here 15, and 2 into 1 will be 2 plus 1. And 5 is a common here. So 15, 3 2s are 30. So 42 into 30 plus 1. So 5 is a common. Now 42 into 30. Here's a 0. 3 2 is the 6. And 4 3 is the 12 here. It's 1260. We have to multiply 5. So here is a 30, and when we are multiplying 3 2s and 4 3s are 12. Okay. So you can see here when we are multiplying, we will get here 1260. This expression is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So 7 into 6 into 5 into, if I'm taking 5 as a common, so how can I write here 5? There are not 5, here is a 4. Okay. So when there are a 4, then we will multiply. The number is changed. 7 6 are 42 and 4 3 are 12 into, here 2 into 1 will be 2 plus 1 and 5 as a common you can see. So here is a 42 into 24 plus 1 and 5 is a common. Now let's see when we are multiplying 42 into 24. 4 2s are 8, 4 4s are 16, 16 plus 4 will be 20, carry forward 2 and 4 2s are 8 plus 2 will be 10. So when we are multiplying these two numbers, we will get 1008 plus 1 into 5. So when we are adding 1 in 1008, we will get 1009. So 5 into 1009. So 9 5s are 45, 0, and here is a 5. So you can see this is a 5045. When we are doing prime factorization of this number, we will get here 7 into, let's see what is the prime factorization. When we are doing prime factorization of 5045, it's not divisible by 3, we'll go with 5. 5 ones are 5, 0, 5 nines are 45. So it's 9109. So here it's divisible by 7. So 7 1 just 7. No, it's not divisible by 7. So I think it's divisible by, it's not 109. It's 100, 1009 here. Now I can see. Okay. Now it's divisible by 7. 7 1 just 7. Here is a 3, 30. 7 4 is a 28. 2. No, it's not divisible by 7. Let me check. 5 ones are 5, 0, again 0. So it's 5 nines are 45. Okay. So it's not divisible by 7, then 1000, 1009 here. So 1009 it's divisible by 11. Yes, it's divisible by 11. Go 9 times. Again I go 9 times. Right? Yeah. Here I go. That's right. It's divisible by 11. Let's see. If we are going 9 times, we'll get 1. No, it's not divisible by 11. Because when we are going 9 times, it's 99. And 99, when we are subtracting from 100, we will get here 99. Sorry, 19. So I think 1009, 1009 is a prime number, I think. So this number is not divisible by any number. Okay, 1009 is a prime number. So this number is divisible by itself. 1009 is divisible by 1009. But according to the composite number, you can see here the factor of this number, which is 5, but composite number has more than factor of 1 and itself. So you can see here the factor is 5 is also. So we can say that this expression is also a composite number. Okay. So this is the question number 6 which we have done. Okay. So I can write here this expression is a composite number which is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. Now comes the next question, which is the last question of this exercise, which is question number 6. Sorry, question number 7. Now come to the question number 7. Question number 7 saying is there is a circular path around a sport field. Sonia takes 18 minutes to drive one round. Okay, of the field. While Ravi takes 12 minutes for the same. Suppose they both start at the same point. And at the same time also. And go in the same direction. After how many minutes will they meet again at the starting point? Again at the starting point. Let's see the question first. Here question is saying there is a circular path around a sport field. Sonia takes 80 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Okay. So since both Sonia and Ravi move in the same direction and at the same time, so the method to find the time when they will be meeting again at the starting point is LCM of 18 and 12 we have to find. Okay. So therefore we have to find LCM of these two numbers, which is 18 and 12. So Therefore, here two numbers, which one is 18 and second one is 12. When we are finding LCM of these two numbers, this both number is divisible by 2. Here is a 9, 6, 2, 9, 3. Both number is divisible by 3. So here is a 3 and a 1. And 3 is divisible by also 3. So it's 1 and 1. So LCM of these two numbers, which is 2 2s are 4. 4 3s are 12. And 12 3s are 36. So LCM of these two numbers is a 36. It means Sonia and Ravi will meet again. I can write here Sonia and Ravi will meet again at the starting point after 36 minutes. After 36 minutes. And this is the LCM of these two numbers. So I can write here LCM of 18 and 12 will be 36. This is the question number 12, which we done here. And this is the last question of exercise 1.2. Okay, guys. So we will meet in the next video with exercise 1.3. In that video, we will discuss about irrational numbers. Okay. Okay, guys. So bye.